Hi all, this is Hani. Welcome back to our channel Code with Hani. Today we are going to solve September day 22 LeetCode challenge, which is count elements with maximum frequency. Okay, so we will be given an array nums consisting of positive integers. Return the total frequencies of elements in nums such that those elements all have the same frequency. So among maximum frequency, how many total elements present, all those frequency we have to add. Okay, the frequency of an element is nothing but number of the occurrence of that element in the array. Got it? So nums, so here we'll be getting 1 2 2 3 1 4, right? So here if you see 1 and 1 present 2 times and 2 present 2 times, so in total what is the frequency? 4. So among this maximum frequency is 2, how many elements present? 2. So if you add those two frequencies, whatever the frequency will come, that is the output. I hope the question explanation would make sense. Now let's take a look how we are going to approach this. So frequency, if frequency it comes in a place itself, we know that we have to store it somewhere, then only we can calculate, right? Okay, the same element exists before, so you have to update that count. Got it? Basically we have to do hash map, right? So yeah, this is the example that they have given. Now basically how we know that some frequency is this, and among that what is the max frequency, so we will be storing like this, right? 1 is present 2 times, 2 is present 2 times, 3 is present 1 times, 4 is present 1 time. So this is our frequency map. Okay, once you know the frequency, we'll be traversing through all these values, whichever is max value. If the max frequency is less than this value, then update the max frequency equals to the corresponding value and set the count to 1, because we have to return the total number of uh, frequencies, right? So if it is present 2 is present 3 times, you if you know the count, so 3 start 2 and you know the max frequency, you can return as a 6 as an answer, right? Yeah, that's what. So if the max frequency is uh, equals to whatever the value you are getting, okay, another element which has the same frequency exists. So yeah, this is the approach that we are going to use. So basically what we are doing, we are taking a frequency map, which is nothing but counter of nums you do in Python. You will get this inbuilt as a frequency map, or you can traverse for num in nums. So you can have, instead of this, you can have an empty dict and or default dict, so you don't need to handle so many cases. So let's have a default dict of int. Okay, so what we'll be doing, frequency map of num plus or equals to 1. So which means when 1 comes, whatever the initial default dict will take it as 0. 0 plus 1 is 1. When another 1 comes, already 1 is there, so again this also will return you this. Either you can use frequency map counter or you can by yourself you can do, but after this we know we will be getting this frequency map, right? Now traverse for value in frequency map dot values. So we want write all these values to compare what is the max frequency. So we'll be having max frequency equals to 0 and count equals to 0 initially. So if max frequency is less than value, which means some frequency has more, so we have to return the total frequencies of a number who has the max frequency. Okay, so that's what. So now the max frequency is our value and are setting initial count to 1, because we found one element. L if max frequency is equal to value, the same frequency exists another time, so count plus or equals to 1. Okay, now 1 count will be getting updated to 2. Now in return what you will be doing, count multiply by max frequency. Got it? Yeah, by this, so by this we can able to figure out total frequencies of elements who all have the maximum frequency. Got it? Yeah. Now let's take a look at the time complexity and space complexity. Here time complexity is order of n. Basically we are traversing order of n, and thus order of u. U is nothing but unique values, right? So in total it will be order of n. The space complexity is order of u because you are storing the frequency map of num. Okay, this might be equal to n to the max, whatever the number they are giving. If all the values are unique, 1, 2, 3, 4, 5, 6, 7, like this, if they have given, all the values are unique. So its hashing will be like storing a reference or something, right? So yeah, in total we will be knowing that it's order of n elements. So another approach we can think of is using a time bound array approach. Okay, bounded range in the sense here we don't know what will be your n, right? So our space complexity will be order of u to the max order of n if everything is unique. Got it? So instead of using it frequency dot counter, what we will be doing, will be having a array. They have told nums will be range from till 1 to 100, right? So you are taking array of length 100. Okay, now what we will be doing, you are traversing through the same num plus or equals to 1. Frequency map of num plus or equals to 1. So here already num will be present, right? So num is nothing but 0. It will be present in 1 to 100. So the same, we'll be having max frequency as a 0 and count will be having as a 0. So if max frequency is less than frequency map of num, which means then you are updating max frequency equal to frequency map of num, count equals to 1. Else max frequency equals to frequency map of num as the same. Instead of using a counter and you are storing it in a hash key value, here you are using array bound approach. So now the since it's a fixed, the space complexity might be going from order of u to order of 1. Only that is the difference. So here count will be getting incremented to another one, return the same star maximum frequency. I hope this makes sense to you guys why we are from order of this is a little space efficient, because you are not storing key as well as value, you are just using an indexing and to figure out which is the num. And so yeah, by then we'll be saving little more space compared to the previous approach. So order of u to order of 1 is the difference between the both approaches. I hope this clear to you guys. So if you have questions or feedback, please feel free to leave a comment in the comment section. I'll be glad to assist. The GitHub link to these solutions will be provided in the video description for your reference. You can check it out. If you found this video helpful, I would truly appreciate if you could like, share and subscribe. Your support motivates me to do more videos daily. Yep, keep supporting. Yep, thanks for watching.